Alright, what's up guys? Now we're going to be talking about rate of change. And this chapter is very similar to the chapter that we did before on slope of tangent, except it's just going to be word problems now. So rate of change, let's start off with a definition. So it's basically how much the dependent variable is changing per 1 unit change in the independent variable. So the dependent variable will be your y, or your f of x, and your independent variable will usually be x, t, whatever the variable in the equation is. So like in the previous chapter, you'll be dealing with two types of rate of change: average rate of change and instantaneous rate of change. So the average rate of change, as a review, is between 2 points, x1 f of x1 and x2 f of x2. And the average rate of change you just find by taking finding the slope between the 2 points. So f of x2 minus f of x1 over x2 minus x1, which is y2 minus y1 over x2 minus x1, rise over run. The second type of rate of change is the instantaneous rate of change. As we mentioned before, it's at 1 point, a and f of a. And to get the instantaneous rate of change, we have to find the slope of the tangent, and we use the difference quotient, which is the limit as h goes to 0 of f of a plus h minus f of a all over h. Just one more note on this chapter. A specific case of rate of change that you'll be dealing with is position and time functions, or position and time graphs. So the position is the dependent variable. The time will be the independent variable. So you could have it as an equation. So S is represents the distance, is equal to some kind of function in terms of t, where t is the time. Or you can have a graph. So the dependent variable position is on the y-axis, the independent variable time is on the x-axis. And the most important thing to note about position time functions is that the rate of change for position time functions is the velocity. So sometimes it allows you to find the average velocity or the instantaneous velocity. So how do you find the average velocity? I probably sound like a broken record at this point, but repetition doesn't hurt. So it's the slope of the secant between 2 points. The instantaneous velocity, you find the slope of the tangent at 1 point using the difference quotient.